Hello everyone, welcome to Schneider Electric PLC training tutorials where you will learn Schneider Electric PLC programming. In this lesson, we are going to learn how to wire PLC inputs and outputs. First, we will start with the wiring of PLC inputs. The wiring of PLC inputs can be done in two ways depending on the type of inputs. The inputs can be of sync type or of source type. We will start with sync type wiring. In a sync type wiring, the common terminal of the module is connected to the 0 volt, and the other side of the terminal and the other side of the supply terminal is connected to one end of the switch or of our sensor. So this is a 24 volt 8-point discrete input sync type module wiring. So as you can clearly see here, when the switch is closed, there is a bit in the memory. There's a logic 1 in the memory, and this input now becomes true. So this for sync type, this for the sync type input wiring. So our module act as a sync. That is where the name is coming from. Sync type input wiring. Then we have the source type input wiring. Here the common terminal is connected to 24 volts, and our switch is connected to the module and the 0 reference and the 0 volts. So here when the switch is closed, there is a bit in the memory, and current flows from the module through the switch to the 0 volt. So here our module acts as a source module. That is where the name is coming from, source type input. So our module acts as a source, and when the switch is closed, the current flow from the module and drains to the 0 volt through the switch. Now, what is the essence of having source type input wiring and sync type input wiring? The reason is because we have two types of sensors. Our sensors can either be a PNP sensor or an NPN sensor. When our sensor is a PNP sensor, then we use a sync type module, because PNP sensor, when they are activated, they provide 24 volts to their output terminal. So that is why syncing type input module are used for wiring PNP sensors, while for source type input wiring we use NPN sensors. NPN sensors, when they are activated, they provide 0 volts. They provide a zero reference. So we use NPN sensors for source type input wiring, and it's always good to check the configuration of the module, so that you will be able to understand what type of sensor you can use to wire it. So this is an example of an 8-point discrete input source type wiring. Next, we will talk about how to wire PLC outputs. So our outputs can be of two types. It can either be AC type or DC type. So usually most modules are configured to have or are designed to support 2 amps of current. So when our module can support up to 2 amps of current, when our load can support up to 2 amps of current, then we can connect it directly to the module. So you can see here we have an AC load, and this AC load, assume that is an AC load rated 2 amps of current, and we'll connect it directly. When there is a logic, when the output is true, then the AC load is turned on. And this module is an AC-DC module, so it can support both AC loads and DC loads. AC loads of up to about 230 volts and DC load of 24 volts. Now what happens when our load can draw more than 2 amps, like when the motor is connected to a load? So in that case, we are going to we'll be using a relay coil. Okay, so I've prepared tutorials on how relay functions, so you can head over to our site at Expert Learning Zone to see how relay functions. But basically, how do relays function? So a relay has a coil, and when that coil is latched, or when that coil is supplied by some rated voltage, the contact closes. So that is the principle we are using here. So we use our PLC module to latch that coil, to activate that coil, and when that coil is activated, it contacts. So you can see this is a coil and this is its contact. When that coil is activated, a contact closes and the power flows from our positive, okay, to our negative, flows from our lifeline to our neutral line, because that relay contact is now closed and our load can now be energized through that live to neutral line. So this is an 8-put relay output module. You can have some modules can go to 16, some can be up to 64, and so on. So it depends on the module that you are working with. Like for example, a typical example of a Schneider output AC/DC relay module is the GRA1605 relay module, but it is a 16 output module. Okay, a 16 output module. So when we are connecting our AC loads of up to 2 amperes, we use this configuration, and when we are connecting our loads which can draw more than 2 amperes, then we use this configuration. Next, we have DC loads. So the principle is the same. So for DC loads, if the load is up to 2 amperes, then we can supply it directly by using the module. And if it is more than 2 amperes, then we connect it through a relay, and that energizes it through a 24 volts, or through whatever voltage that the DC load is running on. Okay, so these are the different wiring for greater than 2 ampere load, and for greater than 2 amperes load, and for less than or equals to 2 ampere load. All right, so that will be it for this presentation. Here in this presentation, we have learned the different inputs wiring, the sink type, the source type, the different output wiring, outputs that are more than 2 amps, and output that can go up to 2 amps. Okay, so thank you very much for watching, and to get detailed access to some of the explicit engineering knowledge you will need for this lesson, please head on to our site at www.expertlearningzone.com. And if you find this video helpful, please like, share, and subscribe. See you in the next video.